Now we'll see the UML component diagram and the deployment diagram. So what is the structure we need to follow for the component as well as for the deployment. So let's start with the component diagram. Component diagrams ranges from simple and we can also provide the high level into the detailed and it will become a complex diagrams. So there are a few of the symbols we use for the component diagrams. So let's have there are a different type of uh, the structures where we can follow for the component diagram. So here we have a symbol rectangle box and there are two at the corners, or else we can also provide big rectangle. Within that we can provide this smaller rectangle that indicates the component diagram indication. So here we need the rectangle box, which we call it as a node symbol that represents the hardware or the software object, which will provide the higher level of the components. Then we can also have the interface symbol that shows the connectivity between the different components can be done using the ball and the socket shapes. How exactly the ball and socket shapes we can make use of it, that we have seen in the previous session for connecting the packages, different type of packages. And here we can use a smaller rectangle box along with a line that indicates the port symbol that specifies a separate interaction point between the different components from the external component to the environment. With a small square box we can use. And we have already seen how the package symbols looks like. The rectangle box and the top corner indicates the name of the packages. So where are the attributes can be a classes, or it can be interfaces, or it can be any other subsystems. We have already seen that. And if you want to write the explanation or the details or the description about any of the node, we can make use of the node symbol to write the description about the particular component. And there are solid lines and the dashed arrow we can use. That dashed arrow indicates the dependency between the different components. How to use these component shapes and the symbol. The component shape we can write if the name of the component is the order, we can use the double angle brackets with the help of writing the name component. Or we have the second one, we can write the name of the component and at the top right corner we can write the symbol. Or we can also mention the name, component and the symbol along with the name. So there are three different ways we can write the indication of the component diagram. So all together how we write in the class diagram, it's similarly the name of the component on the top and the attribute list, means what are the different type of interfaces we are providing with the component description can be written in the second compartment. So it is similar to the class diagrams. So we can add the multiple attributes along with the different interfaces, whether it is the required interfaces or provided interfaces. Along with that, we have two different interfaces, provided and required. So look at the symbol here. There is a full circle connected with the arrow. Connected with this connector, it indicates a provided interface. Means if anybody would like to connect with the component, they can use this. It is a required interface, means there is a interfaces is necessary. It is required between any two components. So we have to merge these two interfaces. Then it will become a ball and socket diagram for the connectivity, or it provides the interfaces between the two different components. So the main purpose of using this component diagram, it gives what is the scope of your system, and we can able to see the overall structure of the software system, how it looks like, and what is the main goal of the system to help them to human and non-human entities, such as we call it as actors, which the actors discussion we have already done in the use case diagram. So let's see an example of the library management system. It is the name of the component. Along with that, we have a different component called the book, and there is a relationship. We wanted to search for the book. So there is a connectivity between the search book as well as in the book. So we have to use the connected symbol. So we have provided the interface here. And we have to do the transactions. There are different types of transactions, different packages. So we have used the package symbol here. and it is connected with the library member. The transaction can happen whether the person is a library or it is a non-member. So it depends on the transaction. So there is a dependency is involved in the both the component. So package is also type of a component, but the package contains different set of entities together merged in a transaction. In a variety of ways we can do the payment. So that we have seen in the package diagrams. So this diagram gives the connectivity, or it includes the structure called package diagram as well as the component diagrams. Everything exists in a single file. So then how the component diagrams looks like we have seen. Just see how the complex system can be written in detail. So there are three different components. Let's take it A, B, C. And here the component has a provided interface as well as the required interfaces. So this interface is required between the main component as well as the component A. That's why the ball and socket connector is used. If there is no circle, then we call it this is the required interface. And we can also have a port for the connections. And along with the port, we have the provided interface. If you want to show the dependencies, the dashed arrow we have to use. And there is a component with different entities. So this is the complex structure for the component, where in detail we are elaborating the component of components, every component. Then how the deployment diagrams look like. The UML deployment diagrams are used to display the relationship among the runtime components and the nodes. So components are here self-contained entities that provide services to other components or the actors. So here we can see one example, web server and the web browsers, how both are connected and what kind of services they are providing to the user. So there will be a node called as a physical device, or we can call it as execution environment. In that the component must be executed. So let's see the example how it looks like. So whole deployment system is composed of interacting runtime components. Means in the deployment, if you want to deploy any devices, there should be an environment. In that environment may contains multiple components. So there is a relationship between the deployment and the component. In every deployment, multiple components are exist, can be distributed among the several nodes. Further, the node can contain another node. So the device can contain a execution environment. In UML deployment diagram, the nodes are represented by boxes containing component icons. There will be one box. Within that, the component icons will be there. So that together is trying to represent it is a deployment diagram. Node can be stereotyped. Stereotyped is nothing but it is a angular, the double angular brackets. So that indicates the physical devices, it exists and there is a relationship. So communication path is nothing but can be represented using the solid line, the line connectivity between the two different components. So again, what type of connection both the components have, we need to write the name on the association using the stereotype symbol. That is nothing but the 2 lesser than and 2 greater than symbols. Just look at this diagram. Here, there are two different type of browsers. These are the component exist within this environment. So the name of the environment is a Mac system, and here the name of the environment is a PC system. Within that, we have a Internet Explorer as a component, and here browser Safari as the component. So both the deployments, and they are trying to connect with one more deployment. Within that deployment diagram, web server is one of the component. That means two different web browsers are trying to contact the web browsers, requesting for information. That information will be gathered from the database. Here database is acting as one more component. So here the deployment diagram with two web browsers, they are trying to access the server. Directly we will not get any reply or any content from the web server. Always the server will be requested to the database to get the information. So for that connectivity, how can we get the data? With the help of JDBC connection, information can be captured from the database and it will be delivered to the web server. From that we can forward it to the requested browsers. So this is how the deployment diagrams looks like. In the deployment diagram in the figure 1, it always focuses on the allocation of the component to the node and provide the high level view of each of the component. Components can be refined further to include more information about the interfaces and what type of interfaces they are providing. Is there provided interface or compulsory the required interfaces? What information they contain can be elaborated. That is the detailed information we can mention in the deployment diagrams. So here further web browser having two different type of services. So that can be connected with the provided interface HTTP service and HTTP the DB request. So here DB proxy, because we are getting the reply from the through the JDBC connection, we are trying to fetch the data from database. This is how the in detail elaboration of the one of the component of the web browser. So this is how the difference between the component diagram and the deployment diagram. So finally, many components will be present on the given deployment diagrams.